The universe is an arena of unimaginable violence. We orbit a calm star on a temperate planet, but beyond our sky lies a cosmos of extremes that defy all human experience. We are about to journey through 50 facts that reveal these terrifying and beautiful environments. You will discover worlds with oceans of boiling water, stars hurtling through the void, and planets made of solid diamond. What strange force could fling an entire star from its galaxy? And what lies at the heart of a cosmic void so vast it could swallow thousands of our Milky Ways? Where do you think we might find the most alien landscape in our entire cosmos? Our journey begins close to home, cosmically speaking, with a world that redefines what an ocean can be. Gliese 1214b is a super-Earth orbiting a red dwarf star about 40 light-years away. It is a water world, but its seas are nothing like the tranquil blues of our own planet. Imagine a single planet-spanning ocean, not of refreshing water, but of a superheated, soupy fluid. The atmospheric pressure on this world is immense, so crushing that it fundamentally alters the nature of water itself. Deep below its steamy, vapor-filled sky, the water is compressed into a bizarre substance known as Ice 7. This is not the cold, crystalline ice we know. It is a hot ice, a solid that forms under such extreme pressure that it exists at temperatures that would make water boil here on Earth. This creates a seascape of utter alienness. You would find yourself on a shoreless sea, where the very depths below you are a solid, scalding slab of ice, while a thick, hot atmosphere presses down from above. It is a world of water in its most extreme and terrifying forms, a place where the very concept of an ocean is turned inside out. Yet even the strangest of oceans might be outshone by a world of pure treasure. 55 Cancri is a planet that orbits so close to its sun that a single year passes in just 18 hours. This proximity bathes the world in unimaginable heat, but its true nature is forged from what it is made of. Astronomers believe this exoplanet is incredibly rich in carbon. Under the intense pressures within its interior, that carbon has likely been compressed into a crystalline structure, forming a vast core of diamond. We are not talking about a few precious stones scattered in the rock. This core is thought to be larger than our entire Earth, a single, brilliant gem of a world. The very ground on this planet, if you could stand on a surface heated to thousands of degrees, would be fundamentally alien. It is a landscape where mountains might be forged from graphite, and the bedrock itself is a lattice of sparkling carbon. What would it be like to stand on a world of such impossible wealth, where the ground beneath your feet is a gemstone of planetary scale? This discovery challenges our very ideas of what constitutes a planet, revealing worlds that are not just balls of rock and gas, but places that can become monuments to the most extreme chemistry the universe can conjure. But even a diamond planet is anchored to a star, bound by gravity to a cosmic home. Some stars, however, are not so fortunate. They are the exiles, the hypervelocity stars flung from their galaxies on journeys of eternal solitude. These stellar projectiles begin their lives in the chaotic hearts of galaxies, often as part of a binary pair orbiting one another. Their doom is a close encounter with the galaxy's central supermassive black hole, a gravitational monster of unimaginable power. When this binary system drifts too close, the black hole's immense gravity can violently tear the pair apart. One star is captured into a tight orbit around the void, while the other is catapulted away at a staggering speed, often exceeding 1 million miles per hour. This is not a gentle nudge into a new orbit. It is a gravitational slingshot of such ferocity that the star achieves escape velocity from the entire galaxy. It then becomes a lone wanderer, shooting through the profound darkness and emptiness between galaxies. For eons, it will travel through a desert of nothingness, its light a solitary beacon in a sea of black. What must that journey be like, to burn for billions of years with no planets to warm, no stellar neighbors for comfort, only the infinite cold void ahead? These stellar exiles are not the only cosmic bodies defying simple classification. Lying in the gray area between gas giant planets and faint stars are the enigmatic brown dwarfs, and their atmospheres are theaters of perpetual violence. These substellar objects lack the mass to ignite sustained nuclear fusion in their cores, so they do not shine with the steady light of a true star. Instead, they glow a dim, deep red with the intense leftover heat from their violent formation. This internal furnace drives weather systems of unimaginable ferocity. Their atmospheres are a churning soup of hot, turbulent gases where colossal storm systems rage. These are not temporary weather patterns like the hurricanes on Earth, which form and dissipate in days. On a brown dwarf, the storms are eternal, planet-wide features powered by the object's own slow cooling. They whip clouds of hot, vaporized minerals and salts through skies of crushing pressure, and within these tempests, the very clouds can condense into a truly alien form of precipitation. In the cooler upper layers of the atmosphere, where temperatures can drop to a searing 2000 degrees Fahrenheit, iron vapor can cool just enough to condense into droplets. This results in a relentless, scorching rain of molten iron falling through alien skies. It is a world of endless twilight, lit only by its own internal glow, where the very air is a blistering, storm-racked ocean and the rain is made of liquid metal. While some worlds are forged in fire or sculpted from diamond, others are actively torn apart by invisible forces. Jupiter's moon Io presents a landscape of perpetual, violent rebirth, all caused by the relentless gravitational pull of its colossal parent planet. Io is caught in an eternal tug of war between Jupiter on one side and its sister moons, Europa and Ganymede, on the other. This orbital dance is not a gentle rhythm. It is a brutal, continuous process of stretching and squeezing, flexing the entire moon as it travels. This gravitational stress does not just distort its shape. It generates immense internal friction, heating Io's interior to a molten frenzy. The result is a world that is, by a staggering margin, the most volcanically active place we have ever observed in our entire solar system. Its surface is a chaotic canvas painted in garish yellows, oranges, and reds, colors that betray the abundant sulfur erupting from its hundreds of active volcanoes. These are not the occasional eruptions we see on Earth. They are a constant planet-wide event with colossal plumes of sulfur and superheated silicate rock shooting dozens of miles into its thin atmosphere. Vast lava lakes bubble and churn, their surfaces constantly rupturing. The very ground is a fractured crust of volcanic plains and towering mountains, some taller than Mount Everest, all built and destroyed by this endless volcanic torment. It is a world where the planet itself is the furnace, its heat generated not by a distant sun, but by the crushing embrace of a giant. While Io burns in inner fire, another moon in our solar system presents a landscape of profound and frozen calm. Saturn's largest moon, Titan, is a world shrouded in a thick, hazy orange atmosphere, a place where the very rivers and lakes are composed of substances that would be natural gas on our own world. The surface temperature here is a bone-chilling 290 degrees below 0 Fahrenheit, a cold so absolute that water is harder than granite. In this deep freeze, methane and ethane take on the roles that water plays on Earth. They exist as vapors in the atmosphere, condense into clouds, and fall as a slow, gentle rain. This rain carves river channels through water ice bedrock and collects in vast, dark lakes and seas that dot the polar regions. One of these, Kraken Mare, is a sea of liquid hydrocarbons so large it would be considered a major body of water on our own planet. The shorelines are not of sand, but of a tar-like organic sludge, and the waves, if they exist at all, would move in a slow, syrupy motion due to the liquid's low surface tension. To stand on the shore of this alien sea would be to witness a hauntingly familiar process, a complete hydrological cycle of evaporation, condensation, and precipitation. Yet it is all built from a chemistry that is utterly alien to our own experience, a chilling and beautiful mirror of home reflected in a frozen hydrocarbon glass. This profound silence and emptiness of space itself creates a bizarre metallurgical phenomenon, one that would never occur within the protective cocoon of our atmosphere. Out in the hard vacuum where there is no air, no water vapor, and no layer of oxidized material to interfere, a strange and almost magical process can take place. When two perfectly flat and clean pieces of the same metal are brought into contact, they can spontaneously fuse together. This is not a process of melting or soldering with heat. It is called cold welding, and it happens because the atoms at the edges of the two clean metal surfaces no longer have any barrier between them. On Earth, our atmosphere quickly coats every exposed metal surface with a thin layer of oxidation, a kind of rust or tarnish that acts like a skin, preventing the raw metal atoms from touching. But in the pristine vacuum of space, that protective skin never forms. To the atoms on one piece of metal, the atoms on the other piece are indistinguishable from their own neighbors. They cannot tell where one piece ends and the other begins, so when they touch, their metallic bonds simply extend across the gap, locking the two pieces into a single, solid object as if they had always been one. This is not a weak bond. It can be as strong as the original metal itself. For spacecraft engineers, this is a critical consideration. Gears, moving parts, and antennae that deploy in orbit must be meticulously designed to prevent accidental cold welding, a silent, invisible force that could seize critical mechanisms and turn a sophisticated machine into a frozen statue, permanently locked together by the universe's own emptiness. These silent, invisible bonds in the vacuum are a testament to the profound emptiness that can exist between objects. But that emptiness is nothing compared to the ultimate voids that define the very architecture of our universe. We often picture the cosmos as a starry expanse, but on the largest scales, it is not a random scattering of lights. It is a cosmic web, a vast, interconnected structure of galaxy clusters and superclusters forming immense, glittering filaments. And between these filaments lie the voids. These are not just pockets of empty space. They are colossal, spherical deserts of nothingness, some so vast they could swallow thousands of Milky Way galaxies with room to spare. Traveling across one of these voids at the speed of light would take hundreds of millions of years, a journey through near total blackness. Within them, you would find almost no galaxies, no stars, and very little ordinary matter. They are the emptiest places we have ever discovered, the negative space in the universe's grand design. To be inside one would be to experience the ultimate isolation, where the nearest major collection of matter is so impossibly distant that the entire concept of a neighborhood of stars would feel like a forgotten dream. What kind of universe builds such immense structures of light and life, only to separate them with deserts of nothing on a scale that defies all human intuition? This crystalline crust is not a solid landscape in any sense we know. It is the outer skin of a neutron star, the collapsed core of a massive star that ended its life in a supernova. The gravity on such an object is so immense it crushes atoms themselves, fusing electrons and protons into a sea of neutrons. The surface or crust is a thin shell, perhaps only a mile thick, of this degenerate matter. Under the unbelievable pressure, atomic nuclei are squeezed into a rigid, crystalline lattice, a perfect grid of matter with no empty space. The density here is beyond human comprehension. A single sugar cube's worth of this material, if you could somehow bring it to Earth, would weigh billions of tons, as much as a mountain. This entire crust, with its unimaginable mass, is often spinning at a frenetic pace. Some neutron stars, known as pulsars, rotate hundreds of times every single second. Picture a sphere the size of a city, heavier than our sun, spinning so fast its surface moves at a significant fraction of the speed of light. The forces at work are titanic. The crust is under immense strain and it can crack. These events, called starquakes, release staggering amounts of energy, causing the star to briefly glow brighter and even altering its spin. What would it be to stand on such a surface? You will be instantly flattened into a thin film, your atoms merged into the very lattice of this spinning, crystalline hellscape, a testament to the universe's ability to create conditions of such extreme and beautiful violence. These cracks in the crust of a neutron star release forces that are dwarfed by the most powerful engines in the cosmos. At the hearts of many galaxies, including our own, lurks a supermassive black hole. But these are not just passive vacuums, silently consuming whatever drifts too close. Some of them are active, and in their ferocious feasting, they unleash the most powerful and focused streams of energy known to exist. As matter spirals inward at incredible speeds, forming a superheated accretion disk, not all of it is doomed to cross the event horizon. Intense magnetic fields, twisted by the black hole's furious spin, can funnel a fraction of this infalling material away from the poles. These are not gentle outflows, they are relativistic jets, beams of plasma accelerated to velocities so close to the speed of light that the laws of physics warp around them. The energy involved is almost beyond description. These jets punch through the surrounding gas of the galaxy itself, stretching for hundreds of thousands of light years far beyond the galactic borders. They are like cosmic blowtorches searing across intergalactic space. Any solar system unfortunate enough to lie in the path of such a jet would be scoured clean. The intense radiation and torrent of high-energy particles would utterly sterilize planets, stripping away atmospheres and boiling away oceans in an instant. This is not merely a destructive force, however. By heating vast clouds of intergalactic gas and regulating star formation, these jets from monster black holes actively sculpt the evolution of galaxies themselves. They are the architects of cosmic structure, wielding the power of creation and annihilation in a single, terrifying beam. What does it mean for a single object to hold such dominion, to direct a force that can dictate the fate of an entire galaxy for billions of years? Such a jet from a galactic core represents the ultimate expression of cosmic power, yet it is a power tied to a specific, violent location. But what of the objects that have been cast out, severed from any such anchor? Drifting through the lightless gulfs between stars are the rogue planets, worlds that have been violently ejected from their home solar systems. These are not merely cold worlds, they are the coldest known places in the universe, their surfaces hovering just a few degrees above absolute zero, the theoretical point where all molecular motion ceases. To stand on such a world would be to experience an eternal, starless midnight. There is no sunrise, no day, no concept of a year. The only light would come from the faint, unresolved glow of the distant Milky Way, a dim smear across an otherwise perfect blackness. The very air, if it had any, would have frozen solid, falling as a slow, perpetual snow of nitrogen and oxygen onto a landscape of bedrock ice. Yet, paradoxically, some of these frozen wanderers might not be entirely dead. Deep beneath their icy crusts, the heat generated by the slow radioactive decay of heavy elements in their cores could be enough to maintain vast global subsurface oceans, sealed away from the frozen surface above. A rogue planet, adrift and alone, could therefore be a dark, silent ark, carrying a secret sea of liquid water through the interstellar void, a hidden abyss where unknown forms of chemistry or even life might persist in total isolation for billions of years. This perpetual cycle of corrosive rain exists on our own planetary neighbor, a world that presents a stark warning of a runaway greenhouse effect. Venus is a planet of extremes, shrouded in a thick, unbroken blanket of clouds that create a permanent, suffocating overcast. These are not benign water vapor clouds like those on Earth. They are composed almost entirely of sulfuric acid, a highly corrosive substance that would eat through metal and flesh with terrifying speed. High in the Venusian atmosphere, where temperatures are somewhat cooler, this sulfuric acid condenses into droplets, forming a genuine planet-wide acid rain. But the surface of Venus is a hellscape with temperatures hot enough to melt lead, soaring to nearly 900 degrees Fahrenheit. As the acidic droplets fall through the dense carbon dioxide atmosphere, they are met with this blistering heat long before they can reach the ground. The rain never touches the surface. Instead, it evaporates in the lower atmosphere, rising back up as a corrosive vapor to once again condense into clouds. This creates a continuous, self-perpetuating cycle of formation and destruction in the sky, a slow, searing drizzle that forever fails to quench the inferno below. It is a world where the very sky is a chemical weapon, endlessly recycling its own venom in a beautiful and terrifying atmospheric dance. Jupiter's magnetosphere is a monster of invisible force, a magnetic bubble so vast it could contain the sun itself, and if it were visible in our night sky, it would appear larger than the full moon. This colossal field acts like a cosmic particle accelerator, snatching charged electrons and protons from the solar wind and from its own volcanic moon, Io, and whipping them to nearly the speed of light. The result is a pair of terrifying, donut-shaped regions encircling the planet known as radiation belts. These are not gentle zones of energy. They are the most hazardous environment in our entire solar system, with radiation levels millions of times more intense than those found in Earth's Van Allen belts. For any spacecraft daring to venture close, these belts are a zone of instant death for unprotected electronics. The relentless hail of high-energy particles would slice through microchips, frying circuits and corrupting data in a flash. For a human, an unprotected visit would be a swift and fatal affair, with the radiation dose delivering a lethal blow in mere minutes. This invisible, crushing force field makes the space around Jupiter a fortress, guarding the gas giant with a shield of pure, concentrated fury that is as beautiful as it is deadly. How does a planet become such a powerful generator, and what secrets lie hidden behind this impenetrable wall of energy? The invisible fortress of radiation around Jupiter speaks of a solar system defined by its giant planets and their violent influence. Yet one of the most profound discoveries in our cosmic neighborhood comes from a tiny, gleaming world orbiting Saturn. Enceladus is a small, icy moon, a mere 300 miles across, its surface so brilliantly white it reflects almost all the sunlight that touches it. For decades, it was seen as little more than a frozen marble, geologically dead and unremarkable. Then, the Cassini spacecraft revealed its secret: Enceladus is alive. Immense fractures, nicknamed tiger stripes, scar its south polar region. From these deep wounds in the ice, colossal geysers erupt into the vacuum of space. These are not plumes of smoke or ash. They are fountains of pristine water ice, organic molecules, and water vapor, shooting hundreds of miles above the surface. This material does not simply fall back as snow. It escapes the moon's weak gravity entirely, feeding a vast, diffuse ring of fine ice particles that orbit Saturn itself. The moon is literally creating part of its planet's ring system, a continuous act of cosmic self-expression. But the true miracle lies beneath the ice. The energy required to power these eruptions points to a global, liquid water ocean, sealed between the frozen crust and the moon's rocky core. This hidden sea is not a stagnant pool. It is a dynamic environment warmed by the gravitational flexing from Saturn, much like the process that heats Io, but with water as the medium instead of rock. The plumes themselves, when Cassini flew through them, tasted of salt and simple organic compounds, the very building blocks of life. This transforms Enceladus from a frozen ball of ice into one of the most promising places to look for life beyond Earth. It is a world with all the key ingredients, liquid water, a source of heat, and the necessary chemistry, all hidden beneath an icy shell. Could those glittering geysers casting material out into the darkness be the sign of a hidden biosphere in the abyss? Is this tiny, active moon silently nurturing secrets in its sunless sea? This volatility in a star's final act brings us to a stellar behemoth living on the very edge of self-destruction. Eta Carinii is not merely a star, it is a hypergiant, a cosmic titan so colossal and unstable that its very existence is a temporary, violent spectacle. Located about 7,500 light-years away, this star system contains at least one star that is millions of times brighter than our own Sun. It has entered the final, most chaotic phase of its life, a period of extreme instability where the outward pressure of its own radiation battles against the immense inward pull of its gravity. This is not a stable equilibrium. The star becomes so inflated, its grip on its own outer layers so tenuous that it can no longer hold itself together. In the 1800s, Eta Carinii underwent a colossal eruption, an event astronomers call the Great Eruption. It was not a true supernova, but a titanic belch, a pseudo-supernova that ejected at least 10 times the mass of our entire Sun into space. This expelled material formed two vast, expanding lobes of gas and dust, which we now see as the homunculus nebula, a permanent smoke ring from one of the largest stellar explosions ever witnessed. Even today, the star remains wildly unpredictable, its brightness fluctuating dramatically as it continues to shed mass. It is a ticking time bomb, poised to end its life in a proper supernova explosion at any moment on a cosmic timescale. This final detonation will be a historic event, potentially outshining the full moon in our night sky and visible even in broad daylight. What must it be like for any potential worlds in that system to orbit a sun that is literally tearing itself apart, periodically shaking the heavens with eruptions that dwarf all other stellar phenomena? The titanic forces that shape galaxies can also warp the very fabric of space-time itself, creating the universe's most powerful magnifying glasses. A galaxy cluster like Abell 1689 is not just a collection of thousands of galaxies bound together by gravity. It is a concentration of mass so immense, containing both the visible galaxies and vast halos of mysterious dark matter, that it creates a profound dent in the cosmic landscape. This dent acts like a lens made of pure gravity. When light from galaxies billions of light-years farther away travels through this region of warped space, its path is no longer straight. The light bends around the cluster just as light bends when it passes through a piece of glass. The result is not a clear image but a spectacular cosmic mirage. The distant galaxies are stretched and smeared into long, thin arcs of light, forming a halo of luminous streaks and sometimes even complete rings, known as Einstein rings, around the foreground cluster. This phenomenon, called gravitational lensing, transforms these clusters into natural telescopes far more powerful than anything we could ever build. They allow us to peer deeper into the universe than ever before, magnifying the faint glow of infant galaxies so we can study them in detail. We are literally using the gravity of one part of the cosmos as a lens to see another, more distant part, revealing the unseen architecture of the universe and giving us a glimpse of the first structures to emerge after the Big Bang. What other secrets might be hiding, magnified and distorted, in the lensed light from these cosmic giants? This stark contrast between stellar violence and frozen permanence finds a perfect example on the sun-scorched world of Mercury. The day side of this airless world bakes at temperatures hot enough to melt lead, a direct result of its close orbit around our star. Yet, hidden within the deep, shadowed floors of craters at its north and south poles lies a secret of eternal ice. Because Mercury's rotational axis has almost no tilt, the sun's rays never reach the bottom of these polar depressions. they are cast into a permanent, profound darkness, a deep freeze that has persisted for billions of years. In these sunless chasms, temperatures plummet to hundreds of degrees below 0 Fahrenheit, creating a natural freezer of incredible stability. Here, protected from the sun's heat, water ice delivered by ancient comet impacts has remained preserved, locked away in the perpetual night. It is a paradox of extremes, a world where you could stand in a blistering desert and just a few miles away in a crater's abyss, touch a reservoir of ancient ice older than most life on Earth. What other relics from the early solar system might be hidden in these silent, shadowed vaults, waiting in the cold just next door to the fire? That ferocious light from a galactic core, when viewed from a specific angle billions of light years away, appears to us as the most brilliant and persistent beacon in the cosmos, a quasar. These are not single stars, but the active, superheated hearts of incredibly distant galaxies. At the center of a quasar lies a supermassive black hole, but one that is in the midst of a glorious and catastrophic feast. Vast quantities of gas, dust, and even entire stars are spiraling into the accretion disk at nearly the speed of light. The friction and gravitational stresses within this whirling maelstrom heat the material to millions of degrees, causing it to glow with an intensity that defies all reason. A single quasar can outshine its entire host galaxy of hundreds of billions of stars, blazing with the combined energy of over 1 trillion suns like our own. This staggering luminosity means that quasars, though unimaginably far away, are visible across the observable universe, their light serving as a time capsule from an era when galaxies were young and their central monsters were voracious. To look at a quasar is to peer back in time and witness a galaxy's violent, energetic youth, a period when its central engine was so powerful it could drown out the collective light of every single star within it. What does such a furious beginning mean for the quiet, settled galaxy it must have eventually become? Far from the brilliant fury of quasars in the silent, frozen outskirts of our solar system, a tiny world defies its label as a mere frozen relic. Pluto is a world of active and alien geology, a landscape sculpted not by heat, but by the slow, deliberate flow of ices far colder than anything on Earth. Its mountains are not made of rock, but of solid water ice, a substance as hard as granite at these cryogenic temperatures. And crowning these peaks is a brilliant white cap of methane snow, a detail that transforms this from a simple ball of ice into a complex world with its own unique weather and seasons. But the true marvel lies in the plains. The vast, heart-shaped region known as Tombaugh Regio is not a static feature. It is a colossal glacier, but one made of solid nitrogen, not water ice. This nitrogen ice is so soft and malleable in the profound cold of -390 degrees Fahrenheit that it behaves like a slow-moving fluid. Over millions of years, this frozen nitrogen creeps and flows, filling in craters and carving new channels in a cycle of renewal that is both achingly slow and geologically vibrant. Convection cells within the ice churn, bringing fresh material to the surface in a process eerily similar to the movement in a lava lamp, but operating on a planetary scale and at a pace of inches per year. This means Pluto, a small world in the deep darkness, is still geologically alive, its surface constantly being reshaped by the glacial flow of exotic ices under a sky of perpetual twilight. Our own sun, for all its life-giving warmth, harbors a temper of cosmic proportions. Deep within its churning atmosphere, magnetic fields can twist into knots of incredible tension. When these fields suddenly snap and realign, they do not release a gentle sigh. They unleash a coronal mass ejection, a cataclysm of pure energy and matter. Imagine 1 billion tons of solar plasma, a superheated gas of charged particles, violently hurled into space. This colossal bubble of fire expands as it travels, accelerating to speeds of several million miles per hour. It is a storm of protons and electrons, a tsunami of magnetism racing across the solar system. Most of these eruptions miss our planet, sailing harmlessly into the void. But when one is aimed directly at Earth, our world braces for impact. The planet's magnetic field takes the brunt of the assault, compressing and shaking under the pressure. We experience this as a geomagnetic storm. The results can be both beautiful and terrifying. In the skies, we see the auroras, the northern and southern lights, dancing farther from the poles than usual, a glorious display of solar energy interacting with our atmosphere. But on the ground, the consequences are far more serious. The fluctuating magnetic fields can induce powerful electrical currents in anything long and metallic, most dangerously in our power grids. These rogue surges can overload transformers, causing them to melt or explode, leading to widespread and long-lasting blackouts. Simultaneously, the intense radiation bathes our satellites, frying their delicate electronics and disrupting the global communications and GPS networks we rely on every day. A direct hit from a truly massive coronal mass ejection could plunge continents into darkness for months. A stark reminder that our technological civilization exists at the mercy of our star's volatile nature. Our galaxy's true shape is not the luminous spiral we see in photographs. That familiar disk of stars, gas, and dust is merely the brightest part of a much larger and more mysterious structure. The Milky Way is enveloped in a vast spherical halo of dark matter, an invisible substance that makes up over 90% of the galaxy's total mass. This halo is the galaxy's hidden skeleton, its gravitational foundation. Without the immense, unseen pull of this dark matter, our galaxy would simply fly apart. The stars orbiting the galactic center, including our own sun, move at speeds that defy the laws of gravity as we understand them based on visible matter alone. They orbit so quickly that the centrifugal force should fling them out into the void, just as a spinning carnival ride can toss a rider off if it moves too fast. The only explanation is that an enormous amount of unseen mass is holding everything together with its gravity, a ghostly glue that keeps the stars in their tracks. This dark matter halo is not made of planets, black holes, or any known form of matter. It does not emit, absorb, or reflect light. It is utterly transparent, revealing its presence only through its relentless gravitational pull. For decades, scientists have been trying to identify what this mysterious substance could be, proposing everything from exotic, yet to be discovered particles to primordial black holes formed in the universe's first moments. Yet it remains one of the greatest unsolved puzzles in all of science. We are living inside an enormous, invisible sphere of something we cannot see or touch, a cosmic phantom that dictates the very motion of our sun and the ultimate fate of our galaxy. What is this stuff that makes up the bulk of reality, yet slips through our fingers like cosmic smoke? This stellar diamond is forged in the quiet aftermath of a star's death. When a star like our own sun exhausts its nuclear fuel, it does not go out in a supernova's blaze of glory. Instead, it undergoes a more gentle yet equally profound transformation. It puffs off its outer layers into space, creating a beautiful, glowing planetary nebula, while its core, no longer supported by fusion, collapses under its own weight. What remains is a white dwarf, an Earth-sized ember containing nearly the entire mass of a star. The forces at work here are almost beyond belief. A single teaspoon of this material would weigh many tons on Earth. This incredible density is possible because the star's gravity has crushed atoms together, stripping away their electron shells and creating a degenerate form of matter. The pressure is so immense that the star's very atoms, now mostly carbon and oxygen, are squeezed into a rigid crystalline lattice. In essence, a white dwarf is a planet-sized diamond, slowly solidifying from the inside out. Its internal heat, the last remnant of its stellar fire, is trapped within this perfect crystal with no way to generate more. And so it begins an epic cooling process, a slow fade into darkness that will take trillions of years, far longer than the current age of the universe. It becomes a cosmic tombstone, a perfect glittering jewel adrift in the void, marking the final crystalline rest of a star that once shone like our own. These ghostly halos of dark matter are the cosmic architects of our galaxy, but the most brilliant displays of invisible force occur in the magnetic theaters of our solar system's giants. The orrery of Jupiter and Saturn are not merely larger versions of our own northern lights. They are planet-spanning infernos of energy, colossal in scale, and born from a celestial dance between a world's magnetic heart and its cosmic environment. On Jupiter, the primary engine is not the solar wind, but its own volcanic moon, Io. Io's relentless eruptions spew a constant torrent of sulfur and oxygen ions into space, which are then captured by Jupiter's immense magnetic field. This field, the most powerful of any planet, funnels these particles toward the poles at breathtaking speeds. When they slam into the upper atmosphere, they ignite auroral curtains of ultraviolet light so vast they could swallow our entire planet whole. These are permanent, raging rings of fire, visible only in wavelengths beyond human sight, a testament to a system in constant, violent flux. Saturn's orrery are no less spectacular, but they possess a different, more mysterious character. They are primarily driven by the solar wind, yet they also pulse with a rhythm that precisely matches the planet's rotation. This suggests that Saturn's own magnetic field is somehow locked in step with the deep, hidden currents of its interior. The resulting light shows are not just static rings. They dance, they flicker, and they change shape with an eerie, clockwork precision, painting the polar skies of the ringed planet with shimmering veils of green and red. To witness these displays would be to stand under a sky alive with forces that dwarf our entire world, a celestial canvas painted by the interplay of magnetic might and cosmic particle streams. Beyond the last orbits of the planets, far past the lonely wanderings of Pluto, our solar system does not simply end. It gives way to a realm of deep, cold, and profound silence, a place known as the Oort cloud. This is not a cloud you could see or pass through. It is a vast, spherical shell of trillions of frozen bodies, a swarm of icy planetesimals left over from the solar system's very formation. Its inner edge is 1,000 times farther from the Sun than Neptune, but its outer boundary stretches a full light year into the void, a quarter of the way to the next star. This makes the Oort cloud the true final frontier of our Sun's gravitational dominion. The objects here are not compact worlds like Pluto. They are primordial icebergs, mixtures of water ice, frozen methane, and ammonia, some as large as mountains, others as small as houses, all drifting in a perpetual, starless night. They are so distant from the Sun that it appears not as a warm disk, but merely as the brightest star in an otherwise black sky, a pinpoint of light that offers no warmth. This colossal reservoir is the source of the long-period comets, those spectacular, unpredictable visitors that streak into the inner solar system on orbits that can take millions of years to complete. A chance gravitational nudge from a passing star or the gentle tide of the galaxy itself can dislodge one of these ancient icebergs, sending it on a fall toward the Sun that will last for eons. When it finally arrives, the ice vaporizes in the solar heat, blossoming into a glorious tail that we see from Earth. So every comet that graces our skies is a messenger from this frozen, distant archive, a piece of our solar system's original construction material, delivered from the deepest cold to the heart of our warm planetary neighborhood. The serene beauty of a comet's journey from the Oort cloud belies a far more violent truth about the cosmos. In the darkness between galaxies, the universe occasionally unleashes a scream of pure energy, a flash of radiation so potent it can outshine every star in the observable universe combined. This is a gamma-ray burst. These events are the single most powerful explosions since the Big Bang itself, and they begin with a stellar death of unparalleled violence. When a star dozens of times more massive than our Sun exhausts its fuel, its core does not simply collapse into a quiet neutron star. it catastrophically fails, collapsing directly into a black hole in a matter of seconds. From the poles of this newborn singularity, twin jets of energy and matter are launched at over 99.9% of the speed of light. These are not gentle beams, they are focused lances of destruction, drilling their way out through the dying star and erupting into space. For a few brief seconds, this beam releases more energy than our sun will generate across its entire 10 billion-year lifespan. The light from this flash is so intense that if one were to occur within a few thousand light-years of Earth, it would be brighter than our own sun in the sky, even in the middle of the day. The after effects are even more terrifying. The initial gamma-ray pulse would be followed by a longer-lasting afterglow of X-rays and other radiation, a lethal bath that would scour our planet clean. The high-energy particles would shred our ozone layer, exposing all life to deadly ultraviolet radiation from the sun. The sky would literally glow with a toxic light, triggering chemical reactions in the atmosphere that could generate a pall of brown nitrogen dioxide, blocking sunlight and plunging the planet into a cosmic winter. Any world caught in the crosshairs of such a beam, even from thousands of light years away, would face utter sterilization. The universe is capable of a violence so absolute it can erase biospheres across interstellar distances in the blink of an eye. Yet this potential for life in a sunless sea is not unique to that tiny, active moon. A far larger and more enigmatic ocean is hidden within our own solar system, sealed beneath the frozen, cracked shell of Jupiter's moon Europa. From a distance, Europa is a gleaming world of white and brown, its surface a fractured jigsaw puzzle of ice. This chaotic terrain is the first clue to the secret it holds. The cracks and ridges that scar its face are not static features. They shift and change over time, indicating that the icy crust is floating on a global, liquid layer beneath. The evidence for this is overwhelming. Measurements of Europa's magnetic field, taken by spacecraft flying past, reveal that it is generated not by a molten metal core, but by a global, salty, electrically conductive ocean sloshing just beneath the ice. This is not a small, subsurface lake. Europa's ocean is a body of liquid water that is global in scale, encasing the entire moon. It contains more than twice the volume of all the water in Earth's oceans combined. This vast, dark abyss is perpetually sealed away from the surface, protected from the hard vacuum of space by an ice shell that may be miles thick. But what could keep such a colossal volume of water from freezing solid in the deep cold of the outer solar system? The answer lies in the same gravitational forces that torture its sibling moon, Io. As Europa orbits Jupiter, the giant planet's immense gravity constantly flexes and squeezes the moon's interior. This tidal heating generates enough energy to keep the subsurface ocean in a liquid state, creating a stable, watery environment that has likely existed for billions of years. Down there, in that eternal darkness, there is no sunlight to power life. Yet on Earth, we have found entire ecosystems thriving in the absolute blackness of the deep ocean trenches, sustained not by the sun, but by chemical energy from hydrothermal vents on the seafloor. The same processes could very well be at work on Europa. On its dark, rocky seafloor, where the moon's core meets the ocean, volcanic vents could be spewing mineral-rich, superheated water into the abyss, providing the chemistry and energy needed to sustain microbial life. This transforms Europa from a frozen ball of ice into one of the most promising places in our entire solar system to search for life beyond Earth. It is a water world with all the essential ingredients, a hidden sea of immense volume, a source of internal heat, and the necessary chemistry, all waiting in the silent dark. What ancient mysteries might be swimming in that profound, sunless ocean? A world of water hidden just beneath a shell of ice, far from the sun's warmth, in the deep cold of the outer solar system, a silent tempest rages. The ice giant Neptune, a world of profound blue, is scoured by the fastest winds we have ever recorded. These are not terrestrial hurricanes, but supersonic jets of gas screaming across the planet at speeds that can exceed 1,200 miles per hour. To stand in such a gale would be an impossibility, a force that would shred structures and tear the very air from your lungs in an instant. These furious winds are a profound mystery, for Neptune receives very little energy from the distant sun. The engine for this violence must come from within. The planet is still contracting under its own immense gravity, and this process generates a tremendous amount of internal heat which rises up through the atmosphere. This heat, combined with the planet's rapid rotation, stirs the atmospheric soup of hydrogen, helium, and methane into a frenzy of colossal storms and jet streams. And within this churning blue abyss, an even more fantastic process is thought to occur. The immense pressure deep in the atmosphere may be crushing methane molecules, breaking them apart and squeezing the carbon atoms into a crystalline form. These carbon crystals would then fall through the dense alien air as a perpetual, glittering rain of diamonds. It is a world where the sky itself is a factory for precious gems, a howling, beautiful maelstrom where the very air can turn to stone. This relentless pull toward a hidden destination defines our galaxy's ultimate journey. Our Milky Way is not drifting aimlessly through the cosmos. It is being drawn, along with thousands of other galaxies in our local supercluster, toward a single, mysterious point in the intergalactic darkness. This focal point is known as the Great Attractor, a gravitational anomaly of such immense power that it can tug on entire galaxies from hundreds of millions of light-years away. Our galactic home is rushing toward it at a breathtaking 14 million miles per hour. For decades, the true nature of this cosmic magnet remained one of astronomy's greatest puzzles, because it lies in a direction almost perfectly obscured by the disk of our own galaxy. This region is called the Zone of Avoidance. From our vantage point on Earth, the central plane of the Milky Way is a thick, dusty band of stars and cosmic debris that blocks our view of the distant universe beyond. It is like trying to see a distant mountain range through a dense, permanent fog bank. Early observations could only detect the pull, not the source. What incredible mass could be hiding there, exerting such a force? Further investigation, using telescopes that can peer through the dust with radio and X-ray eyes, has revealed that the Great Attractor is not a single, monstrous object. It is likely the center of gravity for an enormous supercluster of galaxies, a concentration of mass so vast it acts as the gravitational heart of our entire galactic neighborhood. But the mystery deepens because even this colossal structure seems to be just a waypoint. The Great Attractor itself, and everything being pulled toward it, is part of an even larger and faster flow toward something else entirely. An unimaginably huge concentration of mass known as the Shapley supercluster, the single greatest gravitational pull in our observable universe. So our journey is not a simple one. We are caught in a cosmic current, moving from one gravitational well to a far greater one, swept along in a river of galaxies whose final destination lies in the deepest shadows of space. This magnetic dynamo churning within a planet requires a powerful engine, and Mercury's is one of the strangest of all. Deep within this scorched world, a bizarre meteorological event is likely occurring, not in the sky but in the planet's very heart. Mercury possesses a surprisingly strong magnetic field, a discovery that baffled scientists given the planet's small size. A world so small should have cooled and solidified its core long ago, rendering its magnetic engine silent. The fact that it still hums with activity points to a remarkable internal process. The leading theory suggests that Mercury's massive, iron-rich core is not entirely solid or liquid, but exists in a layered, dynamic state. At the very center sits a solid inner core, a ball of iron and nickel under immense pressure. Surrounding this is an outer layer of molten metal, a churning sea of liquid iron. But here is where the magic happens. In the cooler, upper regions of this molten ocean, conditions might be just right for tiny crystals of solid iron to form. Think of it as a metallic mist condensing within the liquid. These microscopic iron flakes, being heavier than the surrounding liquid, would then begin to sink. They drift downward through the molten sea in a slow, perpetual metallic snowfall, settling onto the solid inner core like a layer of glittering hot frost. This constant snowfall of iron releases gravitational energy as the flakes fall, and this release of energy stirs the liquid core, powering the convective currents that generate Mercury's magnetic field. This incredible process, known as core dynamo precipitation, or more poetically as the iron snow, not only explains the persistent magnetic field but also sheds light on another of Mercury's mysteries, its ongoing shrinkage. As the iron snow accumulates and the core slowly solidifies from the inside out, the entire planet is contracting, its crust wrinkling like the skin of a drying fruit over billions of years. A world we once thought was geologically dead is instead alive with a hidden, metallic winter, a slow-motion storm in its heart that shields its surface and sculpts its very form. This faint, cold whisper from the beginning of time is our most profound connection to the origin of everything. Known as the cosmic microwave background, it is the oldest light in the universe, a fossilized echo of the Big Bang itself. For the first 380,000 years of cosmic history, the universe was a searing, opaque fog, a plasma so dense and hot that light could not travel freely. Photons were trapped, constantly bouncing off a soup of free electrons and protons. But as the universe expanded and cooled, a monumental transition occurred. The temperature dropped just enough for electrons to combine with protons, forming the first stable atoms. In that instant, the cosmic fog lifted. The universe suddenly became transparent, and those once trapped photons were set free on a journey that continues to this day. We now detect this light as a nearly uniform bath of microwave radiation that permeates every cubic inch of space, a relic glow that has cooled to just 2.7 degrees above absolute zero after more than 13 billion years of cosmic expansion. This is not the light from the first stars or the earliest galaxies. It is the light from the moment the universe itself became recognizable, a baby picture of the cosmos. And within this seemingly uniform glow, there are tiny, vital imperfections, minute variations in temperature that appear as a mottled pattern across the sky. These tiny ripples are the seeds of all future structure. They are the gravitational wells into which matter would eventually fall, giving birth to the first stars, the galaxies, and the vast cosmic web we see today. Every galaxy cluster, every star, and every planet, including our own, owes its existence to those faint wrinkles in the fabric of the newborn cosmos. The same magnetic forces that paint Saturn's orrery also sculpt one of the most precise and baffling weather patterns ever seen. At the planet's north pole, a colossal hexagon stands guard, a six-sided jet stream wider than two Earths placed side by side. This is not a static feature carved into the clouds, but a raging river of air, a wall of wind screaming along its edges at over 200 miles per hour. From above, it looks like a work of alien geometry, a perfect honeycomb cell drawn on a planetary scale. The most incredible part is its endurance. We have observed this hexagonal storm for decades, since the Voyager probes first glimpsed it, and it shows no signs of weakening or changing its shape. It is a permanent, rotating tattoo on Saturn's face, a meteorological machine that has likely been churning for centuries. Scientists believe this bizarre shape arises from deep in the atmosphere, where the differences in wind speeds at various latitudes create a stable, standing wave. It is the universe's own demonstration of fluid dynamics, a natural experiment in how gases behave under the extreme rotation and internal heat of a gas giant. What does it feel like to fly along one of those six edges, to be caught in a wind that has blown in the same perfect pattern for longer than human civilization, a storm locked in an endless geometric dance? This distortion of space-time around a black hole has a profound and mind-bending consequence for time itself. Gravity does not just bend the paths of light and matter, it warps the very fabric of time. Imagine a brave volunteer with a powerful clock falling towards the event horizon of a stellar mass black hole. You, a safe observer, watch through an impossibly powerful telescope. As your friend plummets into the ever-strengthening gravitational field, a bizarre thing happens. Their clock, compared to your own, begins to tick more slowly. It is not a mechanical failure. Time itself is flowing at a different rate for them than it is for you. The closer they get to the point of no return, the more dramatic the effect becomes. The ticks of the clock stretch from seconds to years, then to centuries, all from your perspective. The clock's hands would appear to crawl, eventually seeming to freeze completely just as they approach the event horizon. They would be frozen in time from your point of view for the rest of eternity. Meanwhile, for your falling friend, their own clock would tick forward normally. They would experience their own time flowing at its usual rate, crossing the event horizon without any local fanfare, drawn inexorably toward the singularity within. This is gravitational time dilation, a prediction of Einstein's theory of relativity that has been verified in far milder forms here on Earth. But near a black hole, the effect is pushed to its absolute extreme, creating a cosmic theater where one person's moment becomes another's eternity. What does it mean for reality that time, the one constant we all share, is so pliable, so easily stretched by the presence of mass? These magnetic knots on the sun do not merely create orrery from a distance. They can spawn monsters on the solar surface itself, colossal funnels of fire known as solar tornadoes. These are not storms of wind, but of plasma, a superheated gas of charged particles so hot that electrons are torn from their atoms. Rising from the sun's surface or photosphere, these structures are immense magnetic flux tubes, twisted into a spiral by the sun's rotation. They can tower over 100,000 miles high, large enough to swallow our entire planet with room to spare. Within these towering vortices, plasma is channeled along the magnetic field lines, spiraling upward at speeds of hundreds of thousands of miles per hour. The tornado does not simply sit there. It is a dynamic, unstable structure, a visible manifestation of the titanic magnetic energy stored in the sun's atmosphere. The real danger lies in its potential to snap. When these twisted magnetic fields become too complex and strained, they can suddenly and violently reconfigure themselves in a process called magnetic reconnection. This event releases a cataclysmic amount of stored energy, often blasting a portion of the tornado's material out into space and triggering the very solar flares and coronal mass ejections that can threaten our technology. To witness such an event would be to see a vortex of fire wider than worlds suddenly unravel and lash out at the cosmos, a reminder that the sun is not a placid ball of light, but a churning sphere of magnetic fury. Mars holds its own volatile secret locked in the cold ground. While its thin atmosphere offers little warmth deep beneath the rusty soil, a strange form of water ice may exist, one that traps methane gas in a crystalline cage. These structures are called clathrates or methane hydrates, and they form under the specific combination of low temperature and high pressure found in the Martian permafrost. Think of them as molecular prisons where water molecules form a rigid lattice that imprisons molecules of methane gas. On Earth, we find these compounds deep under our ocean floors and in Arctic permafrost. On Mars, vast reservoirs could be buried, a frozen legacy from a wetter, warmer past. This hidden cache of methane ice could solve a long-standing Martian mystery. Orbiters and rovers have occasionally detected unexplained plumes of methane gas in the planet's atmosphere. The gas seems to appear and then vanish, a ghostly presence that defies easy explanation. If these subsurface clathrates were to become unstable, perhaps from a small shift in temperature or a meteorite impact cracking the overlying rock, they could release their captive methane in sudden, localized bursts. The implications are profound. Methane in an alien atmosphere can be a sign of two very different things. It could be a geochemical signature produced by simple reactions between rock and water deep underground. Or it could be a potential biosignature, a gas that on Earth is overwhelmingly produced by living organisms. Could these methane whispers be the faint chemical breath of a hidden Martian biosphere, a community of microbes living in the deep aquifers below the frozen soil? Alternatively, for future human explorers, these same methane deposits represent a potential treasure trove. Methane is a powerful fuel. A significant reservoir of clathrates could be mined and broken down to provide both water and methane for rocket propellant, turning a scientific mystery into the very resource that enables a sustained human presence on the red planet. A world we see as a barren desert might actually be sitting on a deep freezer full of potential life and fuel, waiting for us to unlock its cage. This mysterious pull of the Great Attractor is itself just part of a far grander and more puzzling cosmic current. Astronomers have observed that entire clusters of galaxies on scales that defy comprehension are streaming in a coherent direction. This is not the gentle expansion of the universe, but a directed, purposeful flow, as if a cosmic river is pulling them along. They are all moving toward a single point that lies far beyond the edge of our observable universe, a destination we can never see. Scientists call this the dark flow. The sheer scale of this motion is staggering. These are not individual stars or even single galaxies, but massive clusters, each containing thousands of galaxies, all drifting in the same direction against the backdrop of cosmic expansion. The force required to move such unimaginable amounts of mass must be titanic. The leading theory suggests that the gravitational pull originates from a structure so immense and so distant that its light has not had time to reach us since the beginning of the universe. It could be a concentration of mass on a scale we have never witnessed, a supercluster, or something even more exotic, whose gravity reaches across the void to tug on everything in our local cosmos. This discovery challenges the very foundation of modern cosmology, which holds that on the largest scales, the universe should be homogeneous and isotropic, meaning matter and motion should be evenly distributed in all directions. The dark flow suggests a profound lopsidedness to reality, a cosmic tilt that hints at realms and structures existing beyond our cosmic horizon. What unimaginable architecture lies out there in the unseeable dark, whose gravitational whisper is enough to steer the course of thousands of galaxy clusters on an eternal journey into the unknown? The alien seas of distant water worlds may have a floor of solid fire. Deep within the oceans of super-Earths like Gliese 1214b, the crushing weight of the water itself creates a pressure millions of times greater than anything at the bottom of our Mariana Trench. Under this immense force, the very nature of water is transformed. The molecules are squeezed into a highly ordered, dense crystal structure known as Ice 7. This is not the cold, brittle ice we know. It is a superionic ice, a form that remains solid even as temperatures soar past 600 degrees Fahrenheit, a heat that would instantly flash any earthly ocean into steam. Imagine an ocean where you could dive down deeper and deeper into increasingly hot water, only to finally reach a bottom that is not a soft seabed of silt, but a searing, solid plain of crystalline ice. This hot ice floor would be the foundation for the entire alien sea, a barrier between the churning, superheated liquid above and the rocky mantle of the planet below. It creates a bizarre, layered world where the fundamental states of matter are inverted, a place where solidity is born not from cold, but from the universe's own relentless, crushing embrace. What strange creatures might evolve to navigate the boundary between a boiling ocean and a floor of scalding stone? The crystalline crust of a neutron star faces a far more violent fate when that star is a magnetar. These are the universe's ultimate magnets, neutron stars gifted with a magnetic field so powerful it defies all earthly comparison. If you could bring a magnet halfway to the moon, its magnetic field would effortlessly erase the data from every credit card on Earth. This unimaginable force is stored in the star's rigid crust, placing it under perpetual, unbearable strain. The crust is locked to the spinning magnetic field, and as the field evolves and twists, it stresses the crystalline surface to its breaking point. Eventually, the crust cracks. This is a starquake, a seismic event on a stellar scale. The energy released in a single one of these ruptures is more than our sun will emit in 100,000 years. All that pent-up ferocity explodes outward in a blinding flash of gamma rays and X-rays, a pulse of radiation so intense it can temporarily outshine every other source in our entire galaxy. For any hypothetical planet orbiting a magnet, a starquake would be an apocalyptic event. The initial flash would deliver a lethal radiation dose in an instant, sterilizing the day side and triggering atmospheric chemistry that would poison the night. The magnetic fury alone would rip away any protective atmosphere, leaving a scorched and barren rock. A magnet reminds us that a star's death can create more than a silent tomb. It can forge a raging, unstable leviathan whose occasional shudders can scream their violence across the interstellar gulfs. This cobalt blue world is a masterpiece of cosmic violence. From a distance, the exoplanet HD 189,733b shines with the deep, inviting hue of a tranquil ocean world, but this serene color is a lethal lie. It is the signature of an atmosphere thick with silicate particles, the very stuff that makes up glass on Earth. Here, the temperature soars to nearly 2,000 degrees Fahrenheit, hot enough to vaporize rock. The silicate particles in the upper atmosphere are superheated into a fine, molten vapor. As this vapor rises and cools slightly in the planet's upper atmosphere, it condenses into tiny, solid shards. This is not a gentle rain. The planet is tidally locked with one scorching face permanently pointed toward its star, creating a brutal temperature difference that powers a global hurricane of unimaginable ferocity. Winds scream across the surface at 5,400 miles per hour, nearly 7 times the speed of sound. These are not winds that rustle leaves or topple trees. They are a supersonic sandblaster made of glass. The newly formed silicate shards are caught in this eternal, screaming gale, whipping across the landscape in a horizontal blizzard of razors. To stand on this world would be to be flayed alive in an instant, scoured by a storm of microscopic glass moving faster than a rifle bullet. It is a world of beautiful, deadly color, where the sky itself is a weapon and the very air you would breathe is a cloud of cutting edges. How does a planet become such a perfectly calibrated engine of destruction, where the atmosphere itself turns into a raging, crystalline hellstorm? That serene background radiation, the faint whisper of the Big Bang, tells a story that begins with a cataclysm of unimaginable speed. To explain the universe's large-scale smoothness and structure, cosmologists propose a truly mind-bending event, cosmic inflation. In the very first moments, a fraction of a second so tiny it defies human intuition, the universe was a subatomic speck of pure energy. Then it happened. A bizarre field, an inflattened field, is thought to have dominated the cosmos, causing space itself to expand at an exponential rate far faster than the speed of light. This was not an explosion of matter into pre-existing space, but a violent stretching of the fabric of reality. In less than a billionth of a billionth of a billionth of a second, that initial speck was blown up to a size larger than our entire observable universe today. This incredible growth spurt solved several profound puzzles at once. It explains why the universe appears so uniform in all directions, because regions now far apart were once close enough to be smoothed out. More importantly, it planted the seeds for all future structure. The quantum fluctuations that were present in that initial speck, tiny ripples in the energy field, were stretched to macroscopic sizes by the inflationary burst. These minute wrinkles in space-time became the gravitational seeds, the slight over-densities where matter would eventually clump, leading to the formation of the first galaxies, stars, and ultimately us. Every galaxy cluster and every vast cosmic void we see today originated from a microscopic quantum jitter, magnified to a cosmic scale by the most violent and consequential growth spurt in all of existence. Far from the sun's warmth, the violence of the solar system takes on a frozen, silent form. Orbiting Neptune in the wrong direction, the captured moon Triton is a world of chilling contradictions. Its surface is one of the coldest places we have ever measured, with temperatures plunging to an almost absolute 391 degrees below zero. Here, nitrogen freezes solid, coating the landscape in a glittering crust of exotic ice. Yet this cryogenic world is far from dead. The weak warmth of a distant sun, filtered through Triton's thin nitrogen atmosphere, is enough to trigger a bizarre and beautiful form of volcanism. As sunlight penetrates the translucent nitrogen ice, it heats a layer of dark, trapped dust just beneath the surface. This pocket of warmth vaporizes the frozen nitrogen below, building up pressure until the overlying ice can no longer contain it. The crust violently ruptures and a geyser of dark dust and nitrogen gas screams into the sky. These plumes can rise 5 miles high into the thin air, their dark material staining the pristine, icy surface below before settling back down. To stand on Triton would be to witness a landscape of both profound stillness and sudden, explosive activity, where the gentle touch of sunlight is enough to make the very ground erupt in a slow-motion fountain of ice and shadow. How does a world so cold and distant manage to remain so strangely, quietly alive? Even the ultimate prisons of the universe, black holes, are not completely eternal. According to a profound theory developed by Stephen Hawking, these gravitational monsters can slowly leak their mass away into nothingness. This process, known as Hawking radiation, bridges the seemingly separate worlds of gravity and quantum mechanics. It begins with the strange nature of empty space, which is not truly empty at all. At the quantum level, pairs of virtual particles and their antiparticles constantly flicker in and out of existence, borrowing energy from the vacuum for an immeasurably brief moment before they collide and annihilate each other, paying the energy back. This dance happens everywhere all the time, but at the very edge of a black hole's event horizon, this delicate balance can be shattered. If one of these virtual pairs pops into existence right at the precipice, a bizarre theft can occur. One particle falls across the event horizon, forever lost to the universe, while its partner escapes into space. From the perspective of an outside observer, the black hole has effectively radiated a particle. To maintain the balance of energy, the black hole must pay the cost for this escaped particle. It does so by losing a tiny, tiny amount of its own mass. Over time, this slow, relentless trickle of radiation causes the black hole to evaporate. For a stellar mass black hole, this process is unimaginably slow, taking many times the current age of the universe to even make a dent. But for a much smaller, primordial black hole, the evaporation would be far more dramatic. As it shrinks, the process accelerates, culminating in a final, explosive flash of energy. This means that given enough time, a black hole can simply vanish, leaving behind only a whisper of radiation as a testament to its once devastating gravitational grip. What does it mean for the cosmic cycle that even the darkest and most powerful objects are subject to the faintest whispers of quantum chance? These lava oceans are not serene lakes of fire, but seething, global cauldrons of vaporized rock. Kepler-10b and co-Rho T7b are scorched worlds locked in a death spiral around their suns, completing an entire orbit in less than a single Earth day. This proximity creates temperatures so extreme they can exceed 4,000 degrees Fahrenheit on the star-facing side. At such heat, the very bedrock of the planet cannot remain solid. Silicate rocks, the stuff of our continental crusts, melt into vast global oceans of molten lava. But the violence does not stop there. The intense stellar radiation is powerful enough to boil this lava, lifting vaporized rock and metals high into the sky. This creates a thin, exotic atmosphere not of nitrogen or oxygen, but of vaporized silicon, magnesium, and iron. Imagine standing on a fleeting patch of solid ground, a temporary crust on this churning magma sea. The sky above would shimmer with the heat of vaporized minerals, while the horizon would curve into a perpetual, incandescent glow. At these temperatures, the very concept of weather transforms. It might rain, but the droplets would not be water. They would be liquid rock condensing out of the metallic clouds and falling back into the global inferno below. These worlds are geological furnaces, places where the line between a planet's surface and its atmosphere is blurred into a single, boiling maelstrom, a permanent and violent state of planetary destruction and rebirth. This profound emptiness finds its ultimate expression in the Boötes void, a spherical chasm of near-nothingness so vast it defies belief. Stretching for 330 million light-years across, this region of space is not merely a gap between galaxy clusters. It is one of the largest confirmed voids in the entire observable universe, a staggering bubble of cosmic nothing. If you were to place our Milky Way galaxy at its center, the nearest significant wall of galaxies would be so impossibly distant that the night sky would be almost perfectly black, a starless desert stretching in every direction for millions of light-years. This void challenges the very foundation of our cosmological models, which predict a universe where matter is distributed in a relatively uniform cosmic web. The existence of a vacuum this immense suggests that the distribution of matter in the cosmos is far more lumpy and irregular than we ever anticipated. How could the processes following the Big Bang leave behind a hole of this scale? What kind of cosmic accident could clear out a volume of space large enough to swallow thousands of galaxies, leaving behind only a handful of lonely island universes drifting in the dark? The Boötes void stands as a silent, cavernous mystery, a stark reminder that the universe's grand design still holds pockets of profound and puzzling emptiness. Even the immense pressure that forges planetary diamonds is nothing compared to the gravitational fury at the edge of a black hole. Here, the force of gravity is not a gentle, uniform pull. It is a gradient of such extreme intensity that it creates a tidal force of nightmarish proportions. If you were to fall feet first toward a stellar mass black hole, the gravity at your feet would be unimaginably stronger than the gravity at your head. This difference is not a gentle tug. It is an overwhelming, unstoppable force that stretches your body into a long, thin stream of atoms. This process has a name as vivid as the reality it describes: spaghettification. You would be pulled apart not by impact or explosion, but by the sheer variation in the gravitational field across the length of your own body. Every molecule would be separated from its neighbor, forming a single, hot strand of elementary particles spiraling into the darkness. The object that was once you would become a line of plasma, a cosmic noodle added to the black hole's accretion disk. This is the ultimate power of gravity, a force that can take a complex, solid form and reduce it to its most fundamental components in a final, terrifying transformation. What does it mean that the universe contains points where reality itself becomes a one-way street leading only to this elemental dissolution? The concept of an active world extends even to the frozen shores of Pluto's heart. Within the vast, sweeping plains of Tombaugh Regio, the New Horizons spacecraft witnessed a sight that defied all expectation. Lying at the foot of towering water ice mountains were vast, organized patterns of dunes. These are not the sand dunes of Earth or Mars, sculpted by silicate grains. On Pluto, the dunes are made of sand-sized grains of solid methane ice. Their very existence is a profound puzzle. Pluto's atmosphere is incredibly thin, a wispy envelope of nitrogen, methane, and carbon monoxide that is over 100,000 times less dense than our own air. How can such a tenuous atmosphere muster the force to lift and move solid particles, carving them into landscapes so familiar and yet so alien? The answer lies in a combination of Pluto's unique geology and its tenuous but active atmosphere. The process likely begins with methane freezing directly onto the mountain peaks as a bright, frosty frost. When the feeble sun rises over this distant world, even its weak light is enough to sublimate this methane frost, turning the solid ice directly into a gas. This sublimation provides just enough of a lift, a gentle breeze in the nearly non-existent air, to carry the tiny methane grains down from the mountains and out across the flat nitrogen ice plains. There, the persistent, if gentle, winds organize them into vast dune fields that stretch for miles. This discovery transforms Pluto from a simple, frozen ball into a world of dynamic and interconnected systems, where geology and a whisper-thin atmosphere work in concert to shape a landscape of breathtaking complexity at the very edge of our solar system. Our journey through the solar system is cradled within a vast, invisible shield. This is the heliosphere, a colossal magnetic bubble blown into existence by the solar wind, a constant stream of charged particles flowing from the sun. Its boundaries stretch far into the void, a full 100 times farther from the sun than Pluto's distant orbit, marking the true edge of the sun's dominant influence. Within this protective cavity, our entire planetary system travels through the galaxy, insulated from a far more dangerous environment. The space between stars is not empty. It is flooded with galactic cosmic rays, high-energy atomic nuclei accelerated to nearly the speed of light by distant supernova and other cosmic calamities. These particles are a relentless, invisible rain, and they are deadly to life as we know it, capable of shredding DNA and posing a significant hazard to any unprotected traveler. The heliosphere acts as our first and most important line of defense. The sun's magnetic field, carried outward by the solar wind, deflects and slows the majority of these incoming cosmic bullets. It is a dynamic, living boundary, constantly flexing and reshaping itself as our solar system moves through different regions of interstellar space. Without this benevolent bubble, the background radiation levels on Earth would be significantly higher, potentially altering the very course of life's evolution on our planet. We sail through the galaxy within a temporary haven, a fragile pocket of calm maintained by our star's ceaseless exhalation. But this protective bubble we inhabit is a fragile thing, a delicate balance that can be shattered by the very star that gives it life. We can see the ultimate consequence of this cosmic imbalance on our own planetary neighbor, a world that followed a path of terrifying escalation. Venus presents us with a stark and permanent warning of a runaway greenhouse effect. It likely began with a sun that was slightly warmer in its youth, enough to raise the temperature of Venus just a little. This small increase began to evaporate water from its early oceans, releasing water vapor, a potent greenhouse gas, into the atmosphere. That vapor trapped more of the sun's heat, which raised the temperature further, which evaporated more water. This created a vicious, self-reinforcing cycle, a climatic feedback loop with no off switch. The planet was soon caught in a thermal trap, its own atmosphere turning against it. Temperatures soared past the point where liquid water could exist, and the oceans themselves began to boil. All that water vapor in the upper atmosphere was then broken apart by solar radiation, its hydrogen escaping into space forever. With its oceans gone, the planet's carbon cycle, which on Earth locks carbon dioxide away in rocks and seas, ground to a halt. Any carbon dioxide outgassed from volcanoes remained in the atmosphere, accumulating over billions of years until it formed the crushing, superheated blanket we see today. Venus was transformed from a potentially habitable world into a permanent inferno, its surface hot enough to melt lead, all because of a chain reaction that once started could not be stopped. It is a sobering lesson written across our sky, a demonstration of how easily a world's climate can spiral into an irreversible hellscape. This rhythmic pulse from the void is not a stellar heartbeat, but the work of a celestial lighthouse. A pulsar is a neutron star spinning at a fantastic rate, its intense magnetic field focused into beams of radiation that erupt from its magnetic poles. If these poles are misaligned with its axis of rotation, the star sweeps these beams through space like a cosmic searchlight. For a distant observer, each time a beam flashes across our line of sight, we detect a pulse of energy. This creates the blinking effect, a metronomic tick of radio waves, X-rays, or gamma rays that can be breathtakingly regular. The fastest of these cosmic flywheels, known as millisecond pulsars, spin hundreds of times every second, their pulses arriving with a precision that challenges our best atomic clocks here on Earth. We are essentially watching the universe's most accurate timepiece, a city-sized remnant of a supernova, spinning with such flawless rhythm that it can be used to detect the faintest ripples in space-time itself. What would it be like to witness this up close, to see the sky strobe with the light of a dying sun, ticking off seconds with the unwavering cadence of a force that conquered chaos? The idea of a single sunset becomes quaint when you discover a world that orbits not one, not two, but three separate suns. In the system HD 131,399, a young and massive planet named HD 131,399, AB carves a path through a gravitational dance of stellar giants. For most of its 550-year orbit, two of the stars would appear as a brilliant, close-knit pair in the sky, while the third, brighter star would follow its own, more distant path. On such a world, you would witness not just a single dawn, but a triple sunrise, each star cresting the horizon in a slow, majestic procession. The daytime sky would be a tapestry of multiple shadows and a complex, shifting light. But the true alienness of this world is revealed over its long year. As the planet swings to the far side of its orbit, a bizarre transition occurs. The three stars, from the planet's perspective, draw closer together in the sky until they set in unison. This marks the beginning of a season of perpetual night, a period lasting for about 140 Earth years where the suns never rise, leaving the planet bathed only in the faint, reflected light of its own moons. Imagine a century of unbroken darkness, followed by another century of constant daylight. This celestial ballet is only possible because the planet orbits the brightest of the three stars at a great distance, while that star itself is locked in a gravitational embrace with its two stellar companions. It is a fragile arrangement, a cosmic fluke that demonstrates how planetary systems can form in the most complex of stellar families, creating environments where the very concepts of day, night, and season are rewritten on a scale that dwarfs human history. Our journey through these 50 cosmic extremes reveals a universe of staggering power and violence, but all of it follows a certain order, a set of physical laws that allow for both creation and destruction. Yet these very laws point toward a possible final state of such absolute chaos that it eclipses every other environment we have explored. This is the theoretical Big Rip, the ultimate dissolution of everything. It hinges on the nature of dark energy, the mysterious force driving the accelerating expansion of the cosmos. In this scenario, dark energy is not a constant. It is a phantom, a form of energy that grows stronger over time. As the universe continues to expand, the density of dark energy increases, becoming ever more dominant. For billions of years, its influence would be subtle, but its power would grow inexorably. The first casualty would be the cosmic web itself. The gravitational glue holding galaxy clusters together would be overwhelmed, and these vast cities of stars would be flung apart into the void. Next, the expansion within our own galaxy would accelerate. The delicate gravitational dance that keeps our solar system orbiting the galactic center would be broken. Our sun and its planets would be scattered into the deepening darkness, each becoming a lonely wanderer in an ever more empty universe. The violence would then come home. The force of expansion would eventually surpass the gravity that holds our solar system together. The sun's grip on Earth would fail, and our planet would be cast adrift into the freezing, starless night. But the end would not stop there. The phantom energy would continue to intensify, its repulsive force growing until it exceeded the electromagnetic forces that bind matter together. Earth itself would be torn asunder. The mountains, the oceans, the very ground beneath your feet would be pulled apart. Finally, in the last fleeting moments, the expansion would rip through the fabric of atoms themselves. Atomic nuclei would be shredded, protons and neutrons would be pulled apart, and the very building blocks of matter would be dissolved into a thin, cold mist of fundamental particles, spreading across an infinite and eternally empty space. The universe would not end with a collapse or a freeze, but with a final, silent scream, a last tear in the fabric of reality where every single connection, from the galactic to the subatomic, is permanently severed. After witnessing such terrifying and beautiful extremes, one question lingers. Does our existence in this brief, calm moment make our universe more precious or more terrifyingly fragile? From the silent, crushing rain of iron on brown dwarfs to the horizontal glass storms of alien worlds, these 50 extremes reveal a cosmos of breathtaking violence and beauty. We have wandered through landscapes where the ground is a single diamond, where entire stars are flung into the void, and where the very fabric of space and time can be stretched and torn. This journey paints a picture of a universe not of serene emptiness, but of constant, dynamic, and often terrifying transformation. Our own world, with its gentle oceans and temperate skies, is the profound exception, a rare oasis of calm in a storm of cosmic chaos. It is a humbling realization that we exist on a tiny, fragile rock, orbiting an average star in a quiet corner of a galaxy that is itself just one among trillions. The sheer scale and power of these environments puts our own existence into a new and startling perspective. We are temporary guests in a universe that operates on a level of grandeur and ferocity far beyond our daily lives. Which of these facts left you the most awestruck? Was it the hidden ocean on Europa, the screaming winds of Neptune, or the ultimate silence of the Boötes void? Let us know in the comments below, and if you enjoyed this journey to the edge of reality, subscribe for more explorations into the deepest mysteries of the cosmos.